copied out, so you can go through this again for practice. Practice is really important. And so, periodic table, vital, and on the flip side, our polyatomic ion chart, also vital. So we'll be referring to these.
Thank you.
Okay. So starting with this idea of multivalent metals. So we go to the periodic table and we see, okay, metals on this side of the periodic table have this number, the valence. So this number represents how many electrons this atom has lost, which now makes it an ion.
Okay.
So lithium always just loses 1, so it always has a charge of positive 1. All of these alkali metals do that same thing. That's why they're a family. That's that characteristic that Mendel went, oh, they all behave the same way.
Yeah.
Okay, so that's what makes them an alkali metal. Right next door, we have, in these alkaline earth metals, 2 electrons that have gone away. So now we have a charge of +2. So, just a quick refresher. This cut and paste that we did, where we made pictures. Okay? So when I say alkaline earth metal, that's like calcium here. So calcium as an ion has those 2 places that it wants to combine. Because it's lost 2 electrons, it has a positive 2 charge. So it wants to find 2 electrons extra to fill that gap.
Okay.
Okay, so if we remember our Bohr diagram, I'm going to draw lithium. Okay, so lithium has 3 protons in its nucleus. So that means it has 3 positive charges. As an atom, it has 2 electrons in its inner orbital, only 1 electron on that second orbital. That's the one that flies away. So when it does that, it still has those 3 protons. Those are the positive charges. Now it only has 2 electrons. So you got +3, -2, overall charge of +1.
Okay.
So some metals only ever form one kind of ion. So we can see these ones all lose 3 electrons. How many does this one lose?
4.
Yes. And this one?
Same thing.
But what about titanium? It's kind of wishy-washy.
Do you subtract the 1?
Well, what we have here is a metal that sometimes loses 4 and sometimes loses 3, which is why we call it multivalent. It can form more than one kind of ion.
Okay.
And those ions behave differently. They're sort of different forms of that atom. On this worksheet, we have all atoms that are multivalent metals as positive ions. What they're combining with are non-metals. So these, over on this side of the periodic table, only form negative ions, and they do that because they get extra electrons. Okay, they take a long time to draw. I'm not going to draw, but you can imagine. Okay, so for instance, fluorine, it has 9 protons. It normally has 9 electrons. And in that, actually, I can just tweak this. We'll change it from being this lithium. All I have to do is change the number of protons. So the 3, we're going to overwrite and say, okay, 9 protons. Now it's fluorine. If it has 9 protons, that's its atomic number. That's now fluorine. It has 9 electrons as an atom. So we've got already 2 staying in the center. So 3, 4, 5, 6, 7, 8, 9, And there's that space there where one more electron would fit really well. That is what happens. The electrons that have wandered away from a metal is going to join in here to fill that outer shell. And so now it's going to have a total of 10 electrons, but still 9 protons, which means that's why chlorine, fluorine, all of these halogens become a negative ion with a single negative charge. The next row over, these guys all get 2 extra electrons. That's why they have a charge of 2.
Okay.
How many electrons does nitrogen get?
3.
How about phosphorus?
3.
Yeah.
And same thing with arsenic.
Yeah. And notice these noble gases never gain or lose electrons. They're perfect, right? So when we combine calcium, which is +2, with fluorine, it takes 2 fluorines to match them up. We have 2 positive charges. Fluorine only has a single negative. So now that's why we made these pictures, so you can visualize, those numbers have to match up. And when you get something like aluminum oxide, it can be really complicated. You end up needing 2 aluminum ions and 3 oxygen atoms. Oxygen ions, I should say, to make aluminum oxide. And you can see when we say the name, we just say aluminum oxide, but we write the formula Al2O3, which shows us how many actual atoms of each are in that compound.
Okay.
So how many atoms are in a molecule of aluminum oxide?
No, sorry. 2. I think.
Okay, so there's 2 aluminums.
Mhm.
So each of those is an aluminum atom. There's 3 oxygens. So you have 2 aluminums plus 3 oxygens.
Oh, 5.
5.
Sorry.
Okay. If I look at this zinc bromide, how many atoms in that compound?
3.
Good. Beryllium nitride?
5.
Good. Okay. Definitely making progress here.
Okay.
So now we're going to take everything we know, we've reviewed here, and we're going to put it together and write formulas. These numbers are really important, right? They tell us how many little pluses and minuses each of those have. So remember we did this crisscross method where the number of charges up here goes down below the other one. This crisscrosses down. And so now when we rewrite the formula, so Mn, manganese, bad printing here, is going to have 2 atoms.
And then
Oxygen is going to have 3. That's actually just like this aluminum oxide, isn't it?
Yeah.
So if we change those letters on there from Al to Mn, that would be a picture of this particular manganese oxide. However, when we look at manganese here in the periodic table, it just can't make up its mind. So the top one is the most common kind of ion, but there's lots of manganese ions. So we have to say which one we have when we write the compound name. So that means we write out the name manganese, and then in little brackets we say which one it is. So that number tells us which one it is. It's manganese 3 oxide. So same thing now with lead. Lead is a multivalent metal. Every single one of these is. They aren't all multivalent metals, but on this worksheet they are.
Oh, okay.
Okay, so what would be the formula? What would you write down for lead bromide?
Can I write it? Or?
Yep,
Okay.
it's your turn. That's good. The only thing I would change is there's that negative sign. We only write those signs for the ions, right? These
Oh,
are
okay.
two separate ions. When we put them together in a compound, they're no longer charged. Their charges are sort of neutralized by being matched up.
Okay.
So you can see from these formulas, you just have the symbol, and we didn't have to write the 1 here, because 1s are invisible. If we write the symbol for lead, we know there has to be at least 1 lead.
Yeah.
It's only if we put one of these little subscript numbers that tells us that's how many more.
Oh, okay.
So that's 1 lead, 3 bromines. How many atoms in that molecule?
2 or no.
Well, how many bromines are there?
3.
Right. How many lead?
1.
Put them together?
4.
Okay. So now you're going to write the name of this particular lead bromide. So remember, you're going to need brackets to say what kind of lead it is. Excellent. Okay, and you have neater printing than I do. Okay. Let's see if there's any that are at all tricky. Yes, this one is tricky. So when we do the crisscross here, okay, a 4 and a 2, we would normally write 4 and 2. Now I don't think we have, no, we didn't do any, in grade 9, we didn't have any of our pictures that had plus or minus 4. So I'm going to have to draw on the back of this. So this is what we could visualize. 1, 2, 3, 4. Okay, so that would be our lead 4, right? And we're going to combine it with oxygen that is plus or minus 2.
Yeah.
So if I was to do this just on paper, Pb with its 4 plus, oxygen with its 2 minus, and I crisscross them, right, I'm going to come up with Pb2O4. But when we see the picture of it, we know that oxygen is plus 2, right? It's like this. So it has 2 little spaces. So I'm going to put 1 oxygen here. There's 1. And another oxygen here. And so what we find is it's actually just PbO2. This is just like fractions. We always write it in simplest terms. If you can simplify those numbers, so the lead 2, O4, becomes a 1 and a 2. And this is why.
Oh, I see. Okay.
So you can visualize that?
I'm pretty sure, yeah.
Okay, good. Okay. Same thing if I had, now lead can be lead 4, it can also be lead 2. So if we had that to combine, we'd have Pb 2 plus, O2 plus. You might think, okay, I'm going to crisscross them, Pb, O, and I get 2 and 2. That's what happens when I put the numbers there. But in actual fact,
It doesn't.
it's going to look like that. Oh, that's a 3 and a 3. Do we have, there we go. Magnesium sulfide. Magnesium is a plus 2. Sulfur is a minus 2. They're a perfect match. We only need 1 of each. So just like we simplified this lead 4 oxide, we simplify lead 2 oxide. We cross out the 2's because they're both right, they're the same number.
Yeah.
And it just becomes
PbO.
PbO. So here's